to the P1 training of AMASS. The session of today is devoted to WP6, and the agenda for this session is the following. We start by telling people introducing the topics, then will be some slots for questions, then we will move to the topic management of family lines by MDH and BIF, and finally we will have another session about semi-automatic generation of arguments, also by MDH. Okay, so let's move for the first topic. Do not hesitate to ask any questions, but we prefer you keep your questions up to the end of each section, so that the speaker can explain their things, and then you can ask him questions, so that it can be much more interactive later. Okay, so it's Angel time by Tecnalia, so I am mute, and I transfer you the presenting
Okay. Yes, please.
And now.
Okay. Okay, I'm the presenter. I'm going to share my screen. Good morning, everyone. I'm going to present this first slot. Okay. Excuse me. Okay, this one. I don't know. Okay. Okay. I'm going to show you the new feature in the Assurance Project Generator Wizard to automatically select contents of the standard that will become baseline in the Assurance Project according to a certain criticality and applicability level selected by the user. This feature also is explained in details in the user manual section 6.1. Okay, I have here my prototype P1. I have modeled this LAAP security controls standard, and I have introduced some applicability tables to these requirements. In this case, A+1, A+2, C, whatever. And also this requirement also has its own criticality table to this artifact, also modeling the standard. And this other activity also has A+2 criticality table to this requirement, and the requirement is related also through a criticality table to one method. That is the starting point to create a new assurance project. I'm going to put train. For example, I want to create this train one assurance project, and now after selecting the proper the security controls standard, I can, using these three views to the showing the criticality levels and applicability levels, automatically the contents of the standard are selected according to that criteria. For example, if I choose the second level, I can see that the content selected automatically change. Okay, I'm going to generate A+1 and 2. I don't know how to close this. Okay, maybe with this. I don't know why. And watching this little window. Anyway, okay, and I'm going to generate the safety assurance project according to A+1 and 2 applicability levels. Okay. String 1. Okay. And here is I check the baseline. Are selected exactly the elements according to the selected criteria, and to remember which one was selected during the assurance project generation, we have included in the description of the selected criticality levels and applicability levels this message. And that's all about this new feature of automatical selection of standard contents according to criticality or applicability levels. I'm going to move to the next one. This is a total new window, the Reuse Assistant, that the objective of this view is to reuse contents from the active access package or baseline configuration from one existing assurance project to another. And this feature is also explained in the user manual in the section C.61. Okay, I go back. To open this view, you have to go to Show View, Reuse. I'm going to choose as Tarsus NIST Training 1 Assurance Project and as source the Reuse, another existing project. As you can see, and as I said before, the contents of this assurance project has more elements than appear in the reuse views, because this model only belongs to the active access package and baseline configuration. To reuse something, I can to reuse the whole model. You have to choose the desired model in this list. If we wanted to reuse a concrete part of an evidence, we have to double click over it, and a new tab is open with these three with checkbox in the editor, in where we can choose exactly which part we want to reuse to the target process. I'm going to reuse only, for example, this part, and the other models will be used totally. If you click the reuse button, the reuse process will start, and when finished, this message appears, and we go to this train assurance project, and we can see that only the selected parts with checks has been copied, and all the other models, all the elements of the other models. One problem that we have detected, and we are working in a solution, is the following one. When you start, okay, if you start the prototype one and the reuse view was open, from a peer reuse execution of your client bundle, for example, in this case, see that the reuse view is already open. If I choose the source project, I'm going to close this tab. Okay. If I want to reuse only partially this model, the 3 view with checks are not loading. To solve this, you only need to close this view, and automatically the contents, this check tree will be loaded again, and you have to show again the reuse view. And now the contents to be reused will be loaded perfectly. And this is all that I wanted to tell you about this new feature of Reuse Assistant. Now let's move to the last one, to the compliance map report. The objective of this modified feature compared with the previous one is that now you can search compliance gaps according to certain criticality or applicability levels. This feature is also explained in the user manual in the section 6.4.3. Let's move to the demonstration. Okay, I'm going to close this one. If I go to this training assurance project, I go to the baseline of the project. Okay, and we have to choose the best framework element, and now to access this functionality we have to click the mapping table button. And now we have, like in the assurance project wizard, generator wizard, the 3 views to choose applicability and criticality levels. Now all the contents of our project are not defined. These are all the contents of the baseline of the project that has no criticality or applicability levels. And if I choose this one, for example, we can see that we have more elements in this table. And if we choose A+2, we can see that we have also more than before. And I'm going to, for example, create one compliance to this artifact infosec security. I'm going to choose artifact. I have to create the compliance map, compliance map 1, for example, name 1, and I can say that this artifact is fully compliant with this artifact in the evidence model of the project. And now if I can filter by the fully, I can see this one. For example, I have another option. Okay. Requirements. Okay. Not fully and fully. Artifact. Okay, you can see this is easier to see with these filters. The objective is of this of this compliance table is to find compliance gap, to know what things are left in this sample. For example, what things are left to achieve an A+1 or 2 levels in our safety product. And now that's all about my topics. If you have any questions, please ask me now, or you can contact me by email or whatever you want. Okay? No questions? Okay.
No questions? Okay. So
okay.
thank you, Angel.
Thank you very much for your attention.
Okay, so let's move to the next topic, which is Atif's presentation. So I'm giving you presenting rights. Okay, Atif, you can start.
Can you hear me?
Yes.
Okay.
Yeah.
Hello everyone. I will start the training by recalling the variability management expectations in AMASS. Then the background on EPF Composer and BVR tool will be presented. After that, the solution for variability management at process level will be discussed and demonstrated. Finally, the support for variability management at component level will be described and demonstrated. In the context of a AMASS project, EPF Composer would be used for modeling the software system development processes. Chess is selected to model the systems. OpenCert is selected to model the assurance cases. Their underlying meta models, in particularly UMMA, ChessML, SECM, however, do not provide support for variability modeling and management required for our purposes. Therefore, we are working on the systematization of commonalities and variabilities within each quadrant of 3 lines constituted of process lines, product lines, and assurance case lines. Now I will move to the background. Eclipse Process Framework Composer provides support for authoring, configuring, and deploying software system development processes. The underlying meta model is called Unified Method Architecture, abbreviated as UMMA. UMMA supports major parts of the software and systems process engineering meta model STEM 2.0. UMMA defines method library as a root container for plugins and configurations. The configurations point out the working subset within the library. The plugins contains the method content and the processes. Method content offers support for the reusable process content. They are expressed using roles, tasks, work products, and guidance. The categories are required for publishing the process methodologies as a website. Activity is an important element in a process. The descriptors, in particularly task descriptors, role descriptors, work product descriptors, are also specified within the activity. EPF Composer actually supports 2 kinds of patterns. The complete life cycle is modeled as the delivery process. However, the capability patterns are building blocks for a specific key area of interest. For defining a process, the user can take the method content and organize into semi-order sequences that specify how the work shall be organized over time to meet the needs of a particular development process. BVR is a language that is built on top of the Common Variability Language for the necessities of the various project. The idea with the BVR is to support the variability modeling for the safety critical software systems engineering. The language is implemented as a set of Eclipse plugins. The overall implementation is called the BVR bundle, which supports modeling the trio of features and linking the trio of features to the resolution model. The new model is also generated from the realization model according to the options selected in the resolution model. The variability abstraction in BVR or CVL consists of a VSpec, which is the variability model. It's supplemented with constraints. The corresponding resolution models defines the product selections. The base model in our case might be UMA or CHESS ML compliant model. The variability resolution contains the variation points, showing the mappings between the variability abstraction and the base model so that the product or process models can be automatically generated. VSpec is actually an evolution of the feature-oriented domain analysis, usually called feature models. In the VSpec, the mandatory choices have solid lines to the parents, while the dashed lines represent optionalities. We can model the constraints for the choices. For example, for the requirement 5542A of ECSS EST40C standard, in Annex R, it's specified that the requirement is not required for product with criticality D. Accordingly, we have specified the constraint A, B, or C implies not integration and testing software unit, which implies that tailoring is not required for process with criticality A, B, or C. We have applied the multiplicity at the criticality XOR, which means that exactly one out of A, B, C, or D should be selected in the resolution. The resolution models are automatically generated from the VSpec, but the engineers have to specify the true-false choices for the specific resolution or configuration. The resolution models can be executed to check the conformance with the VSpec model. This means that if constraints are correctly specified, valid resolutions or valid generation of models can be guaranteed. We can specify multiple resolutions for a process with variability. For example, in this case, we have specified four resolutions for process with criticality A, B, C, and D. Here, for example, we have selected the D as true because we we have specified the options for the process with criticality. Realization is based on the fragment substitutions. The fragment substitution removes elements within the placement and substitutes them with the elements in the replacement in order to create the placements and replacements. What we do is we drag and drop the elements from the model. We drag the elements from the model and drop them at the realization editor. After that, the create placement or create replacement option might be selected. A placement and replacement a fragment is created which contains a placement and a replacement. For example, we have created a fragment, units, and components. We assign the V-spec to the fragment, which means this placement and replacement bundle, I mean the fragment, will be executed if the assigned V-spec is true in the resolution. I mean the tailoring will be performed if the assigned V-spec is true. Otherwise, the variation point will not be executed. Next, I'm going to present the variability management support at process level, and we will have a demo. We have achieved the seamless integration between process engineering and variability management. To achieve the seamless integration, we import the library from EPF Composer. We make the required adjustments to support the variability management with the BVR tool. The generated models are exported back to the EPF Composer. For importing the library and fixing the validation problems, we have implemented a dialog wizard. The recent or default path choices are automatically filled in the path text box. Otherwise, the users can browse for the other method libraries in the system. For process reuse by EPF Composer and BVR tool, 4 kinds of models are involved. The very first is a process modeled in the EPF Composer. Then we have a variability model called V-spec. We have a resolution model, and we have a model in which variation points are specified. It's called the realization model. It might be noted that XMI is a storage for EPF Composer. So in this case, we have specified the placement to placement fragments over the XMI files. To achieve the desired configuration, the execute option is selected in a specific resolution. For example, we have selected the execute option for the criticality D for ECSS EST 40C. This generates the process models which are automatically exported back to the EPF Composer. The dialog box might be opened to inform that the files have been changed on the file system. Do you want to load the changes? Okay, let's have a demo. We have implemented the command seamless integration between EPF Composer and BVR tool. Okay, the recent path choice is filled. Okay, we click finish. This loads the library as well as the working set of models are are copied under the error-free models. Since we have integrated the EPF composer in AMASS V1 release, we can perform the EPF capabilities, for example, the authoring, browsing, and for modeling and deploying the software system development processes. As we were discussing, the library is a root container. We have to create a new library method library if first to model the plugins and to model the configurations. In the life cycle plugin, as well as in the other plugins, we have method content and processes. The method contents in the content packages, we have roles, tasks, work products, and guidance. In the categories, we have disciplines, domains, work products, kind, role sets that are actually required for publishing as a website. Or if we go in the process section, we can see the capability patterns and delivery process. Let's open one of the process. This process actually concerns section 5.5 of ECSSE ST40C, in which the activities in integration of software are not needed for process with criticality D. So for this, we have specified the WP6 resolution and realization in the BVR tool. Let's go to the other perspective. We have the BVR model. If we don't have it, or for some new models, what we do is we can select new other BVR. Next, we can name the model, and we can select model object as BVR model. Pressing the finish button will create the BVR model. Since we have the model, let's open this one. First, we can open the WP6. The WP6 query model might not be fitted at screen, so we can minimize some options. Okay, so if we click at a choice, we can see the options like add another choice, add choice occurrence. Choice occurrence is actually to cope with the duplications. We can add constraints as well as the types. Here we can also see the constraints, BCL constraints. The constraints actually specifies the tailoring rules mentioned in the ECSSE ST40C, particularly the NXR of particular standard. We can open the resolution editor. In the resolution editor, we can see different configurations for the specific resolution. Let's minimize some parts. Okay. So for the process with criticality D, if we recall from the slide, the activity integration and testing software units should be considered for tailoring. So if I make the choice as false, then there should be a validation error. Yes. So for the product with criticality D, the tailoring is required for the particular V-spec. The third editor is called the resolution editor, in which placements and replacements have been specified. So I will open the associated model. Yes. For example, the placement, this activity is specified as a placement for this fragment substitution, and we have assigned the VSpec integration and testing software unit. So if integration and testing software unit is true, then this fragment will be executed, and this activity is going to be replaced with actually nothing, but we can this is mentioned in the standard, so we are following the standard for the tailoring, but it's also possible to inject some other activities or model elements. Let's go back to the resolution model. We can execute the resolution. Okay, the execution of resolution actually generates the new model. Let's go back to the EPF composer to see whether we have achieved the tailored model. Work breakdown. Yes, we have achieved the tailored model actually in the in this phase. We cannot see the tasks which are required, which are actually not required for a process with criticality level D. Okay, I will then move to the next slide. The final topic is variability management support at component level. JSML does not offer any support for managing variability. The communication of the models needed to manage product variability is similar to the case of process variability management. As with the case of EPF composer, we have 4 types of models. The first model, attitude and orbit control system composite, is modeled in the chess or papyrus editor. The underlying storage for chess and or papyrus is .uml. Therefore, the variation mappings, the fragments have been specified over the .uml file. We have also modeled the variability model, resolution model, okay, and the realization model was also already explained. To drive the specific configuration, we can select the execute option for a specific resolution or configuration. This generates the desired model. For example, in this case, we have removed the feed-forward controller component from the attitude and orbit control system. I mean, from the newly generated model. Let's have a quick demo. We have modeled the VSpec for attitude and orbit control system. We can see that feed-forward controller is marked as optional. We have specified 4 types of configurations for attitude and orbit control system, and in the realization model, we have a fragment substitution for the feed-forward controller. It might be noted that the placements are highlighted in the models in red colors, while replacements in in blue colors. So since we are not currently replacing with any new elements, but as mentioned before, it is possible to replace the model elements with some other elements. Okay. So to drive a new model, we have, as with the case of EPF Composer, we select the execute option. And we can see the message that it's automatically exported back to the chess project. The previous model name is, I mean, the old is appended to the previous model name. We didn't deleted it, and the new model is named as the name of to the name of the previous model. Okay, we shouldn't see the feed-forward controller implementation in the generated model. Okay, I think, yeah, that's it. Thank you very much for your attention.
No more questions? Okay, so let's go to the next one, which is Robert.
Okay.
Okay, perfect.
Thank you very much.
Please start.
So good morning from my side. I'm Robert from Variability. I will show you a second approach or a second application for the PVR and EPF-C bundle. In our example, we will see something about safety and security. In the AMASS tool, in the AMASS project, we have designed a process framework which deals with regulations, process development, process management, and compliance management. In this short demonstration, I will show something about process development with the PVR tool. First of all, I will explain something about the interaction between safety and security, and then I will show you how we deal with the variability management in the PVR. Okay, let's start with this short introduction about the safety security engineering. In our example, we deal with two standards. This is on the one side the security standard, on the other side the safety standard, and we have to identify security and safety activities which are in common. So we call them co-engineering activities. They lead to a common goal, and we define a process in the EPF-C composer, and then we have to export it to a project-specific process. And in this example, I will show you something concerning verification. We have on one hand side the threat analysis and the hazard analysis, and we will have to verify this. And our base process contains all activities which are available in the company or in the process, and we are going to remove unwanted activities. First of all, I will show you the work breakdown structure in the EPF-C composer. Ati said something about the EPF-C composer, so I will show you only the work breakdown structure. Here on the right side in this window, we have all the activities concerning to our short example. We have some verification activities and we have verification methods. In this case, we have only three: system design walkthrough, FMEA, and FTA. And in the following example, I will show you how to remove the FTA from this work breakdown structure and from this project, because it is not needed. So we will go to the variability management part. In this, I will show how to remove this FTA activity. Now we have the EPF-C process, which is a base process which contains all available methods. Now we go to the variability management with the PVR tool. This variability management is based on parameters, and these parameters are implemented in constraints in the PVR model. So our parameters are ASIL and the recommendation level. Here in this figure we have also the security level, but I will not use the security level in this demonstration. What I will show you, we have verification activities, and we have a standard, in this case the ISO 26262 as functional safety standard, and the base process contains all available methods, in this case FTA, FMEA, something else is part of the model. We had this walkthrough, and we will select in the example ASIL B. As you can see here in this table, ASIL B has a plus, which means it is recommended to apply deductive analysis. In difference to plus plus, we do not have to implement this. Plus plus is mandatory, and plus is only if you need it, then you can do it. And so we decide we do not necessarily need FTA analysis, and we will remove it from the process. Before I go to the tool, we have here some variable definitions. In the tool demonstration, we have ABC, in this case double C, and D, which stands for the ASIL level. CC is because of a tool issue. CDC doesn't work in this implementation. We have PP, which means plus plus. This is the highly recommendation from the ISO. We have plus, only recommended. This is the case for ASIL B, and we have the security level. So we go directly to the tool. Here we have the Eclipse environment with the PVR tool. First we have the VSpec diagram. Atif said something about these three diagrams. We have, of course, VSpec, resolution, and realization. Here is the VSpec, and this is the equivalent model of the EPF-C model. Here we have the activities shown before in the work breakdown structure. We have the ASIL, ABCD, we have the recommendation level, plus, plus, and plus, and we have the security level. So we have here the activity define the methods used for verification. Here we have three methods: FMEA, FTA, system design walkthrough. And we want to remove FTA because we are selecting ASIL B for our project-specific process. And how we remove this? We have here constraints. They are defined in this VSpec diagram. And with help of these constraints, we make sure that the process fits to the process has to fit this to the constraints, and the PVR tool makes this sure because we can verify the diagram. This is done in the resolution diagram. Here we have a quite similar view. Here we can select the activities. We have selected ASIL B. This is true. we have selected the ++ option for the recommendation, which means we will only execute ++ activities. We can validate this model, so the response from the program is valid. This means that all these selections are corresponding to the constraints. If I change FTA to false, and then I can do this again. I validate it, and then I get an error message. It's not valid, it's false. Here we have a reason to find the problem. In our case, FTA is not valid for PP and B. So I have to turn it on and have to set it for true. Then it's valid. To explain something about these constraints, if we had in mind the table from the ASIL, for example, we have for ASIL C and ++ is highly recommended. This means FTA has to stay in the specific process, and this means for the PVR tool it is not true. Not true means in this case it will not be replaced. And it's the same for our selection. ASIL B is true, ++ is true, and this means FTA has to be true because it is not part of the final model and it has to be replaced. Okay, I hope everybody can understand this logic. Then we have the realization model. Here the imported EPF-C model comes to the play. Here on the right side is the imported EPF-C model. Here we define placements and replacements. The placement is the activity which is going to be replaced, in this case FTA, which is here in red. The placement, the replacement, sorry, in this case is null. This means we replace the FTA activity with null. This is done with the fragment substitution. You can create the fragment substitution, select FTA from the menu, and if this is done, you can export the model. In this case, it is called execute. Artifact demonstrated this. You can export this. The window will appear where you can select the file name. In this case, I overwrite the existing file. And so this has been exported, and you can import it back to the EPF-C model. And you have removed the FTA activity. So I will not show you how it looks like directly in the EPF-C. I will go back to the PowerPoint to find it. What we have done here is we have a base process with all available activities. We have variables, we have parameters, and we are using the variability management tool PVR. With the help of these parameters, we remove the FTA or other unwanted activities. And so we have the development process, which is a project-specific process. And if we go to the EPF-C, we will see that the FTA has been removed from the work breakdown structure. So this was a quick walkthrough, a second application of the PBR tool. Thank you for your attendance. If you have any questions, please ask. Atif is the tool expert. Thank you for your attention.
Thank you, Robert. Okay, so if we don't have any questions regarding any of the management of family lines topic, we can proceed to the next one. Questions? No questions? Okay. So I transfer rights to Irfan, which is the next one. Irfan, center.
Thank you. Okay. Let's see. Okay, can you see my screen?
Yes, yes.
Great. Okay, I will first make a short presentation to introduce things, and then we will go through the demo in the tool. Okay. So I will go through the part related to the product-based reuse and automatic generation of argumentation from the contract specification in the chess model. So the focus here is on reuse. And when we look at reuse within standards, there was some mentioning of standards before. There are certain concepts that promote reuse, such as the safety element out of context. It essentially enables us or promotes that we reuse components between systems together with their certification information or safety relevant information, such as safety case arguments, the supporting evidence, and so on. And in the example, I'll use the one use case that I had developed before, but in the scope of AMASS, we will do this on the case study 3 and automotive case study. But for the moment, I'm using this wheel loader example. Essentially, if you know, these wheel loaders, they have this lifting arm that can go up and down. And this controller can have automatic positioning component. Basically, if the operator presses a button, then the arm will go into predefined position. But it also has, of course, manual control of the arm. This particular, this is a sketch of the design of this unit. It has this automatic positioning component. It has this arm controller component, and so on and so on. It takes some information about the speed of the vehicle, the inputs from the control lever position by the operator, the angle of the arm, and so on, and it performs its function. What we're doing here in this use case is developing this loading arm automatic positioning as a safety element out of context, that is, as a reusable component that can be instantiated in different systems, and seeing how to reuse information regarding the argumentation and information regarding the evidence that go with that component in different systems. So the rest of the information, of course, needs to be assumed and so on, and we see contracts as ways to capture this information. I'll go through these 2 points. So if we want to do that, if we want to use contracts to help us with reuse and with assurance, we need to answer 2 main questions: how to perform assurance based on these component contracts, and how to support product-based reuse with those. So let's see the first one. If you look at the contract-based design that's supported in chess currently through OCRA, for example, what we do is for each level, for example, this is the loading arm controller unit, the system level or the function level. For all levels, we specify contracts for each component. For example, for this top level, and then we can specify it for the subcomponents of that, like arm position, loading arm, automatic positioning, arm controller, and so on. And then what we do, and the contract here is essentially specification in a pair of assumptions and guarantees, saying that given that the environment in which the component is instantiated in, if it satisfies these assumptions in the contract, then this particular component will guarantee certain behaviors on its own. So to help us with reuse, to help us with assurance, what we do is we associate assurance information with those contracts. So different, for example, requirements are associated with contracts. Explanations of what the contract means. The evidence supporting that the contract actually is implemented in a given implementation, that the actual component behaves according to that contract and so on. So those are all assurance information, assurance assets that are relevant from safety case perspective and that are relevant for use. So we associate all those. So what we did in work package 3, we extended the CACM to support these things such that the contract can be associated with different assurance information such as claims, evidence, and so on. So we added that support, and we will see in the example how that can be done. And then once we have that information in CACM, what we can do, we can make an argument about based on that information. So for example, if we want to assure that the requirement is satisfied with a certain confidence, then the requirement is associated with the contract. We need to say that this contract actually correctly formalizes or implements this requirement, and then we need to assure our confidence in this contract itself. So we do that for each contract there for a particular component. What we need to say there, that this contract decomposition is correct based on specified refinement. So talking about the internals of this component, then we need to say also that the environment in which this particular component operates satisfies its assumptions. And we need to provide also some evidence, if we have, that the actual component behaves according to this contract. Meaning, for example, we can associate here different evidence, such as simulation, testing, and so on, that can support that the component actually behaves like this. Okay. So this is when we talk about assurance and contract and how that works. Now, how to support reuse here. So what we did before, we have these strong and weak contracts to help us with that. If we talk about reusable components, then they're developed independently of the system in which they will be used, and they will usually develop with configurable parameters to tailor their behavior in different systems. So we have this distinction in strong and weak contracts. They help us to say, okay, these behaviors should be always provided, and hence these assumptions should be always satisfied by the environment. And then we have weak contracts, which are context specific, and we can say, okay, this particular handles this environment, and this other contract handles other environment. So if we go back into this design, that would mean that for this loading arm automatic positioning component, essentially it would have several contracts, several weak contracts. And then when we reuse this in this particular system, we need to choose which of these is relevant for this environment and which of these should be connected to this top contract to check if the refinement and the composition is correct. So by filtering which of these weak contracts is relevant for this system and which of these weak contracts satisfies others, that is fits into this environment, we also promote reuse, because then we filter also the assurance assets that have been attached to these contracts. So to say, for example, that this one, if it's satisfied here, then we choose this one, but the other two may not be usable or reusable in this particular scenario. So this is a brief summary of everything. So out of context, we would have a set of strong, weak contracts. Once we reuse in a particular context, then some of those would be selected, some of those wouldn't, and those that are selected, they would be used in the argumentation. So what we had before in chess, we had possibility to specify strongly weak contracts, we had possibility to translate them to Okra and check refinement and so on. What we added in P1, the traceability, so being able to attach this evidence and assurance assets to the contract, to be able to automatically check validity of this weak contract and automatically select which ones are the green ones, are the ones relevant in this particular context. And then we provided support. Once we have that knowledge, then we can automatically generate these arguments based on the information in the contracts and around the contract. So let's see now if we can go through a brief demo. So here you can see block definition diagram for this particular loading arm controller unit. We specify the loading arm controller unit on the system level. We have just 3 components here for simplicity: arm positioning, loading arm automatic positioning, and arm controller. This is how the internal looks, where we have connections of everything to everything. And here, when we define the internal block diagram, that's where we define different or the value of different parameters. So this particular component has several parameters, and for example, we have maximum speed of the vehicle, maximum ground speed. We have ground speed limit, meaning when should this arm be disabled. We have whether this automatic positioning is static or dynamic, meaning if the position is predefined or it's dynamically set by the user. So this is a set of requirements, for example, that go with this particular for this system. So, for example, the stop position of the arm shall not deviate more than a certain amount. The loading arm positioning shall not start without user initiation. The loading arm shall be disabled during high speed, and so on. So what we do there, on the top level, we can define a set of contracts on the loading arm automatic positioning. For example, we here deal with fault propagation. So which conditions need to be satisfied is specified in the assumptions for this component, not to provide, not to return a faulty command, for example. We can have different contracts for different things. We specify contracts on each component, and here we have contract for this reusable component. So here we have set of contracts that talk about different environments in which this component can be reused. Essentially, if we look at number 1, for example, we can see here more details. So this is a contract written in Okra, in Othello specification, which is LTL based. So since not everyone can read that, we have added here possibility to add explanations or descriptions of this. What does this actually mean? So if we see, so it will tell us here if the vehicle can go in high speed, that is, if the ground speed limit is lower than the maximum speed of the vehicle, and it has a static automatic positioning target, then we, for this component, not to move the arm when not supposed to, it requires a reliable ground speed sensor. So, for example, and then we have that for each of the contracts, different explanations. What does this actually mean? And we can also associate some artifacts, evidence, and so on with these contracts. So, what for reuse to happen? What we need to do? What needs to happen when we are here? We need to select. If we go to this component, then some of these contracts need to be selected, which are relevant in this particular system. So what we did is that you can automatically now select these contracts from here. Okay. So how that can be done? Let's see. We have here analysis context. So we have here analysis context, contract refinement analysis context. We can do validation here. Okay, and this will check the model, check the contracts, and tell us which of these weak variants is actually applicable in this particular system. Let's see, it takes a bit time. We select this and this. Okay. So this is the, for example, the output. It tells us that this particular variant is okay, the others are not. We go okay, and if we go back to this here, and we go to the here, we can see that this is again selected. Then if we check it in here, we can see that the status of the contract has been updated to valid in this particular context, while others are not validated in this particular context. So this is the first information regarding the filtering things. Now, when we have everything filtered, then we can go and proceed to generate arguments from this information that we have gathered here. If we check the repository currently, so we'll put it here, we don't have anything. What we can do here, go to chess, argumentation, generate. We select the model based on this contract requirement analysis. Then we select the target. We will put it here. And so this process may take a bit. And it may look non-responsive, but just give it some, have some patience, and it should do the trick. Essentially, what this is doing is creating for each component in the system one argumentation diagram presenting its contracts and relation to the relation between them to the requirements and so on. Let's see. Okay, argument fragments are generated. So if we go to OpenCert, we can see here that they are generated. So we can open, for example, the top level, and we can see we may need to extend things so we can read. So the system contracts, and then for each of these contracts, we have specification here, descriptions, context statements about different things. Perhaps it's not very readable in this diagram, so we can see here. So for example, this one tells us that this contract formalizes this particular requirement. It leaves us place to actually argue that this is actually correct. We can see here context regarding what does this contract actually mean. We have here also the composition of the contract requirement, where actually this points to subcontracts that this particular contract depends on. So for example, we can see here that these are the contracts in the fault propagation in ARM positioning, fault propagation in ARM controller, and in the loading ARM automatic positioning. If we go to the respective diagrams, we can see there the corresponding contracts that are referenced there. And we can also see if a contract is validated, then it will have this support. If something is not validated, then it will show us this challenge or counterexample in diagram, saying that okay, we need this to be true, but the model says that this has not been validated. Hence, we have this also here. Okay, and based on that, we can check here that there are certain connections. Okay, this is from previous instances, but here we can see there are automatically created connections between the elements in the chess model and the elements in the OpenCert in the assurance. So for different things, we will have different connections, which is facilitated by Capra. Okay, and that would be all from my side.
Okay, thank you. Let's move to the next one, which is Faiz. Okay, so I transfer him rights, presenting rights. Faiz, unmute, presenter. Yes. Okay. It's your time, Faiz. Faiz, are you there?
Yeah. Are you listening?
Yes, right now, yes. Perfect.
Yeah.
Please start.
Okay, I am the last present for the training sections, and my topic is the semi-automatic generations of arguments, in particular the process arguments. First, I will give you the agenda of my presentations. I will discuss about the overview of the process-based argument generations, and then I will provide the background information, in particular the process modeling with EPF composers, delivery process, in particular exporting delivery process in the XML format, and the creation of or specification of the assurance project in OpenCert in order to generate the process-based argument. Then I will go to our plugin generating the process-based argument, and in the last I will give you a demonstration. For the process-based argument within the AMASS region, the development process plan needs to be fulfill the standards and should provide the justifications of the compliance. The initial idea in this context will be already presented in the MD-SafeSer technique within the context of SafeSer project. In particular, the idea behind the mapping of the process element into the argumentations. For this, we have to model the process in the Eclipse framework, EPF, which is compliant to the UMA meta models, and which has to be compliant with the arguments, which is compliant to the CSA meta model, and have to be visualized in the OpenCert, which is rendered by the concrete syntax of the goal structuring iterations, GSM. The initial idea was that the process element, in particular the task descriptor, are mapped into the claim or the goal, and the elements that are associated to the task descriptor, such as the set of the roles. These are the roles, and they are mapped into the strategy, and because dividing into the goal into the sub goals. And the evidence related to the role descriptor, tool mentors, work products, and examples are mapped into the evidence of evidence, and it should be the solutions in the GSM. Actually, the creating and manual mapping of the process element into the argumentation required a lot of time, and it is an annual task. So we have provided the generations of the process elements to the argumentation by using the model-driven technology. In particularly, we use the Epsilon transformation language for this purpose. And the mapping between the other elements of the process models and the argumentation model is provided into the deliverables AMASS Developer 6.2. Now I will discuss about the modeling of the EPF composer. This is already discussed some of the context of the EPF composer. Actually, EPF Composer provided multiple options to work and create the process models. Either you can use create your own method content elements, or you can use the existing library. Here you can see the main elements of the EPF Composer is the plugin, and which consists of the method content elements and the processes. In the method content element, you have the content packages and the categories. The process elements in the method content reusable process elements are defined, such as role, task, work product, and guidelines. And the process, in particular, in the EPF Composer, it contains the two processes like capability pattern and the delivery process, and to organize the elements in the semi-order of the sequence in the context of specific project. In order to generate the process-based argument, we consider the delivery process, and the creating the elements and the process models in EPF is provided in the EPF user manual. In particular, we have considered the work structure of the processes. For instance, we have considered the task descriptor that has the information about the task within the process. And the task has the references to the task on which it is then based on the method content elements. Here you can see the task descriptor and the roles which are associated to this task. And also the EPF shows the work product steps and the guidance which are associated to these tasks in the work product structure. After creating the process model, we have to export the delivery process in the XML format from the EPF. For this, we have used the export functionality which is offered by the EPF Composer. You can see the method and we select the other option. From this, we have particularly select the export one or more method plugins, and then we have to select our plugin which we have created in order to export the XML file. Currently, we have considered that the method plugin has only one delivery process, but in the next iteration, we have provided the more significant functionality. In order to generate the process-based argument, we have to create or select the existing assurance project. The creation of the assurance project provided by the ANHAL in the first presentation slide, and it is also available in the user manual. We have to create the new assurance project and give it the name to the assurance project, and we have to select the reference table which we want to do. So this is the background information which is related to the process-based argument. Now I will go to the work for how to trigger and activate the command for the generating the process-based argument. The options can be activated in the assurance project, and in particular the property view, we have to click there, and then the properties are appeared, and we have to select the EPF Composer argumentation options. After selecting this, the dialog box is open, from which we have to browse the exported process which we have exported by using the EPF Composer XML functionality. We have select this process in the open set, and after selecting this process, we have to generate the process by clicking the generate button. It might be noted that the browsing dialog filters only the .xml file extension only. So after clicking on the generating process, the transformation will be started, and in order to stop the transformation process, we have to click on the OK button, then the close button. And the generated argument model and diagram text will be appear in the text box. If the process transformation has some error, then the error message will be shown in the text box. So here you can the argumentation model which is generated in the OpenCert will be shown in the argumentation folder under the target assurance project. So I will show the in the EPF composer. Here you can see the method controller which I have created, the method plugins and the elements such as like task, work products and the guidance. And for the delivery process, I have selected, and this is the work breakdown structure of the delivery process. Here you can see the activity, the task descriptors, and if I click this onto the task descriptor, you can see the roles and the work product associated to these tasks. So we have to export this by using the export functionality. This is the method authoring of the APF. So we have to select this and export one or more method plugin. And then you have to browse the folder which you want to save this file. And you have to name this. Okay. So the file is exported. And the next we have to select in the EPF OpenCert. So if you have not created the project, you have to create the new assurance project. But I have already created the assurance project, and you see it has the empty argumentation folder. If I click on this, sometimes the repository takes time. So let's see. I think so. I have to re-open it again. Okay. Here you can see the option. We have to select it, and we have to select it, the generated XML file, and press the generate button. So actually the models are generated in the repository, so it takes some time. So you can see the generated argument and the diagram. So the augmentation diagram and models are generated in this. I have taken the screenshots. So in particular, we have mapped the task descriptor into the goal of the GSNs, and we have mapped the ID of the task descriptor on the ID of the goals, and the name of the task descriptor are mapped into the goals name, but I have also used the task descriptor colon so that we can differentiate it is the task description name in the process, and we map into the descriptions into the description of the goal. After generating the augmentation models, currently we have the augmented diagram folder is generated showing the empty editor, and we have to select the elements and drop them into the editor. So in the navigation view, and we have to select it and drop them. After selecting and dropping them the elements, it shows the augmentation diagram elements. In the future, we have to next prototype we will work on to the generations of the diagram, which showing the elements automatically. Currently, I have shown the summary of the work which we have done. In particular, we have mapped the activity into the activity of goal notation, or you can say the claim of the augmentation diagrams, and the task descriptor are mapped into the task descriptor. And in order to specify the elements which are related to the task descriptor, such as in this case, you can see the roles are a set of the roles. We use the strategy, which is divided into the sub goals for each specific roles, and the evidence related to these goals are mentioned in the solutions of the diagram. So these are the references for the user's manual and the work which is presented in the document AMASS, and the initial idea for the assurance case. And thank you very much for your attention. Do you have any questions?
Do you have any questions for this slot or any of the previous ones? Okay, so thank you everybody for joining this session, and remember that during the next days we will have in the other training sessions for WP5, WP3 and WP4. Okay, thank you very much.
Thank you.
Thank you.
Thank you. Bye.
Thank you all.
Bye bye.
Thank you.
Bye.